So today's topic is about Kafka optimization, and we will be looking into various opportunities to improve performance of Kafka. So when we say we want to improve the performance of Kafka, there are multiple aspects. So what is the definition of performance optimization? Like when we want to optimize Kafka, so I'm talking about specifically performance optimization. And actually I'm referring to the throughput, and we are targeting a high throughput, and we are targeting latency, which is low. So our goal today is to look into various aspects of Kafka to achieve maybe high throughput or low latency, depending on your use case. So before we go anywhere, it is important to understand throughput and latency, what exactly I mean by that. So let's say throughput is like how many messages we are able to send or receive or process, because there are different areas within Kafka. So messages per second, right? So that is like process, receive, produced, right? And here we have latency, which is like overall how much time it took to process, right? So how much time it took. So you can have use cases where you need high throughput, or you can have use cases where you need low latency. So it depends on the use case. So a lot of times when you are doing some analysis of, let's say, last 1 year data, this is one example, right? So you are processing or analyzing a lot of data. So you would prefer to have high throughput, because it is kind of processing like lot of data for last 1 year, last 10 years, last 5 years, right? So high throughput. But let's say you are looking for, let's say, Uber uses Kafka for calculating surcharge, calculates search price or surcharge. Yeah. So this is one example where low latency is needed. So let's say you are booking a trip through Uber, and you want to find out what is the extra money that you have to pay, or the total trip fare that you have to pay. So surcharge calculation is happening. So this is a use case where we need low latency. So there are use cases where we need low latency. There are use cases where we need high throughput. So we will be looking into these aspects, like how can we use Kafka to achieve high throughput or low latency. So depending on the scenario that you are working. So I hope you are getting a background, like what is our goal when we are saying Kafka optimization. We are talking about performance optimization, and when we talk about performance optimization, then we are talking about high throughput or low latency. Now there is a complete stack. In this complete stack, you will find we have like infrastructure layer. It can be on cloud, it can be hardware. Now a lot of distributions of Kafka are available, but this is one layer. If you are having control, then this is one layer where you can get a lot of opportunities to ensure that the hardware is as per the expectations. For example, if you use SSDs, then you get better performance. If you use multiple hard disks in a broker machine, then you get better performance, like 6 to 12 hard disks in a single broker. So if you use hardware which is, for example, memory intensive machines, then it is going to benefit you in broker machines. So hardware plays a very important role, and having good hardware is very important for getting a good performance from Kafka. Second layer is operating system or file system layer. So operating system, there are recommended operating systems. If you read the reference architecture of Confluent, you just Google, you will find reference architecture. You will find all the recommendations which operating systems are recommended. And this is definitely Linux based and ext4, and you can get guidelines for other operating systems also. But you need to see where are you running your Kafka cluster. And then this is file system. Specifically, I should talk about the file system rather than like ext4 is a file system. Sorry, it's not. Like operating system is Linux, and specifically ext4 is file system. And this file system, we have opportunities to optimize this OS level parameters. So when we say OS level parameters, you are setting up your Kafka clusters. You have to use various operating system level parameters. For example, ulimit. Ulimit is like number of files which are open by a process, right? So we have to bump that value up in the Linux operating system. So this is ulimit parameter, and there are so many other parameters like vm.swappiness, and there are many other parameters that we have to tweak to ensure that our operating system layer is as per the expectations before we actually deploy Kafka, right? So tuning is needed in each layer. So we have Java layer, so we have to tune garbage collection tuning we have to do, right? So we have to take care of JVM heap size and everything. And then comes Kafka core because it is running on top of it. So there are multiple layers in between. Like if you see on like just below Kafka, there are so many layers, and Kafka core is in between this layer, and there are other layers. So we have ksqldb. So there are optimizations specific to that, Kafka Connect and KStreams API. So there are different layers where we have to do optimizations. But right now, since we are talking about Kafka, so we will be focusing on optimization of Kafka core. And also we will be looking into optimization of producers and consumers. So that is our goal. Like next 1 hour, we will be looking into these aspects. Yeah. So it may be possible that we may not be able to cover every optimization in this 1 hour.
Optimization of Kafka.
Yamurthy, if you're not speaking, you can mute yourself. Okay, thank you. So we are talking about 3 main optimizations today. Like one is producer side, another one is Kafka cluster side, another one is consumer side. So there are 3 main optimizations that we are talking about. So I'm not sure if you got a chance to watch the video that we posted last meetup, and it was on Kafka internals. And there is a video that we posted. I spent more than like around 45 minutes on this, like Kafka internals, and that was focused on producer side. Yeah, thank you so much, Sunidhi. So this was a video that we discussed like Kafka internals, and here we focused a lot on producer side configs, right? So this was the last meetup, and Sunidhi has posted the link also on the chat. So let me do one thing. I will open this video to give a high level understanding, and then we will come back to this discussion of optimization. We have explained various options to optimize producer side. Here in this video, explained a lot of things around partitioner, explained a lot of things about the buffering which is happening on the producer side, how batching occurs in the producer side. And we have already discussed in the last meetup, like what is a batch size. We have already discussed linger.ms and so many other configurations, acknowledgement policy. So we discussed many things in the last meetup related to the producer side architecture. So today, I will not be repeating the same content that we have already covered in the previous meetup. So I would encourage you to please watch that video where we have already covered producer side architecture and everything. So here, when we say producer side, I will quickly summarize what is needed. Like, for example, there are many configurations, but if you see the key configurations which will help you in performance optimization, I would like to capture those. So one configuration is batch.size. Another configuration is linger.ms. Yeah, so based on these two, this is based on size and this is based on time. This is based on size and this is based on time. Based on these two configurations, the batch will be triggered, right? So if you trigger a very small batch size, so what is the trade-off? So trade-off is we have a small batch size, and another one is we have large batch size. So if you have large batch size, then it is good for high throughput. If you have a small batch size, then it is good for low latency. Yeah. So depending on like what is your target, you can configure these properties in Kafka. So we also have buffer dot memory, which is 32 MB. So you can tweak this as well, where the buffering of messages are happening in the producer side. You have custom partitioner, like you can plug your custom partitioner. Definitely developers have to write code for custom partitioner. So this is for controlling how this controls how messages are distributed, across topic partitions, messages distribution across topic partitions. So this is also important point for optimization because you can avoid data skew issues. So you know what is data skew issue? Anyone wants to share what is data skew issue?
And data skew issue is like when we send the data, but like system shut down, then that time the data cannot reach to that Kafka broker.
So skewness means asymmetry in data. Skewness. So skewness means like it may be possible that one particular partition is getting a lot of messages, but other partitions in Kafka are having very less messages. So let's say this is my Kafka cluster. Within Kafka cluster, let's say we have various brokers, and let's say this is one broker, another broker, another broker. So these are different brokers, different machines, broker machines. And here we have, this is one partition. I'm talking about leader partition only. This is another partition. Maybe this is another partition of the same topic. Let's say this is topic one, and this is, let's say this is topic one, and this is partition one, topic one, partition one. And let's say this one is topic one, partition two. This is topic one, partition three. So in this case, I'm ignoring replication right now. I'm just saying that one particular partition in a topic. So there are three partitions, three unique partitions of a topic, and some of the partitions are having a lot of data. And if data skew happens, then it is going to impact the performance of the cluster a lot, because whatever jobs will be running, or like, for example, K-stream applications are running, then they will take longer time. The consumers which are consuming data from this partition, they will take longer because there is a lot of data in this particular partition, and there are chances that the disk can go out of space and you will have issues. So this is skewed data. This is not symmetrical data, right? So this is skewness. Yeah. So this is skewed from data engineering point of view. This is one of the number one enemies for data engineers. So we have to remove this skew, and we have to redistribute our messages in a manner so that we have uniform load right across. And another thing, like from data science perspective, also skewness is not helpful, because a lot of machine learning algorithms, they fail when data is skewed. So I'm just thinking data scientists and data engineers work on these problems of removing skewness from the data, or maybe the way data is being distributed. So right now we are talking about partitioner, which helps in distributing the data in on the Kafka topic partitions. So you can control that distribution by writing a custom partitioner if you are a developer. Okay. So if you have any questions anytime, feel free to unmute yourself and clarify. Now, there are other properties like compression. Yeah. So you have to see, like, do you need a compression or not? Because a lot of times it happens that you are compressing the your data, but what happens, like you are spending compute, right? So you are wasting your compute cycles for compressing and decompressing data, right? It can be done by producer, it can be like decompression can be done by consumer. So it depends how you have set up, but compression is a trade-off. So you are saving the space. It helps, like if you are using compression, it helps in saving disk IO, network IO, yeah, network IO, but compute is impacted. The compute IO will compute will increase. So it's not IO, but disk IO, network IO, compute will be more. Compute need will be like consumed more because of compression. Now, Vicky, if you're not speaking, you can.
संभाल के कभी वापस कुछ करनी पड़ी तो.
Hello, Vicky. If you're not speaking, you can mute yourself. Yeah?
I'm sorry.
No problem. So we are just discussing various opportunities to optimize Kafka performance, and then we were focusing on the producer side. So there are other ways also, but are we clear that like when we talk about Kafka optimization, there are multiple things which are involved. So this is one area like where we have this. So compression, and then there is another one which is called max in-flight requests per connection. So any guesses what exactly it is? Max in-flight request per connection, which is by default 5. So this is another configuration which will help you in tuning Kafka. So I will take a pause. Do you have any questions, or are we do you want to answer this? Like, what is max in-flight request per connection? What is this configuration?
Yeah, max in-flight request say that when the data cannot be reached properly, then producer again want to send the data again.
That is retry. Yeah, that is retry. This is something like, you know, when producer sends data to Kafka, producer does not send directly. It goes into the local buffer in the producer side. And then producer side local buffers, the data will be sent or batches will be triggered to the leader broker once the batch size is completed, right? So I have explained these things in the last meetup, the video that is shared by Sunidhi here in the chat. So if you look at the video, you will understand how overall producer side architecture is working. Yeah, so you can watch that, but I want to focus on this particular configuration specifically. So when requests are actually buffered, so they will be triggered. So how many requests should be in transit? So, you know, you can imagine you are living in a society and you are sending buses from your society to school. Let's say there are so many buses going. So how many buses are plying on the road, right, simultaneously, so at a time, right? So you can say how many requests per broker, like for each broker, how many requests? So 5 parallel requests, 5 in-flight. In-flight means they are in transit. So in-flight requests, 5 in-flight requests are allowed. So it is a trade-off. So if you have more flights going on, then there will be not a lot of network traffic also. But if you have less number of flights going or less number of requests going on from producer side to the broker, then it will be taking less network bandwidth, throughput will be compromised. So it depends. And also ordering part will come into picture, but we can have a separate discussion on ordering. But for the timing, just understand that how many in-flight requests per connection can be sent, right? So that is like by default it is 5, but you can change it. So this is another opportunity to tweak the Kafka performance. So we looked into batch size, we looked into linger.ms, we looked into compression, right? So compression, do you need a compression or like do you want to avoid it? If your consumers are already struggling with compute, so you don't want to compress the data in the producer side, right? And consumer should not be wasting compute cycles to decompress the data. So it depends like how your consumers and are set up. Are you okay to like spend CPU cycles to decompress the data? So there are many compression algorithms which are available. Like you can use 𝐤𝐳𝐧𝐧𝐞𝐜, Snappy, LZ4. There are many algorithms which can be used. Now, this is producer side. When we are talking about Kafka performance optimization, we have cluster side. Yeah. So what are the opportunities to improve performance of Kafka at the cluster side, right? So that is the next question. So let's say cluster side key configuration. So what are the key configurations at the cluster side? Key configs. So any thoughts, any ideas, like what do you think? How can we improve performance on the cluster side? What should we do to improve performance on the cluster side? So do you know architecture? Like if you are not very much familiar, you can go to the link of the architecture. If you watch this video, I have explained where is our architecture video on our YouTube channel, Kafka architecture. So this is architecture video, and this is our Kafka cluster. And then this is producer, this is consumer, and this is Kafka cluster. So we want to improve the performance. So in order to improve the performance of Kafka cluster, you have to monitor it. You have to find out like where the performance is going down. So for monitoring, so monitoring is very important. So very first thing is like we have to monitor. We have to monitor our cluster. So monitoring cluster means you have to see leader count. And leader count is one of the JMX gauge. That means you can find out how many leaders are there per broker. You can also get to know partition count. So if this is also JMX gauge. So if let's say leader count or partition count are not uniform, so then it means that there is skewness or there is a hotspot like in the cluster. So we don't want some brokers to have high leader count or high partition count because in one Kafka cluster where we have zookeeper, then there is a limit of maximum 4K partitions. So we should not hit that limit because 95% of the cluster are still running zookeeper. So you should be cautious about it. Once zookeeper dependency is completely removed from your production environment, then you can imagine like partition count can be very high value, no problem. Maybe 100K plus in each broker. But right now there is a limit like number of partitions that we can have on one broker. It cannot be more than 4K. But usually we try to keep it up to 2K, 2000 partitions. Yeah. So leader count. So we should basically have optimal values, like it should not be very high values. Otherwise, if that broker goes down, then there will be a lot of leader re-election happening and it is going to take time to recover. And there will be a lot of offline partitions. So leader count, partition count, these are some of the interesting things. And there are many other JMX things that we need to monitor for looking at the health of the cluster. So when you are monitoring performance, so all these JMX metrics also you have to see, because it's not about just the configurations. Even from producer perspective, you have to see a lot of JMX matrices, right? So here, leader count, partition count, and then when we look into monitoring, you have to see ISR shrink rate, ISR expand rate. There's another JMX metric. ISR expand rate. You have to see leader election rate, right? So there are a lot of matrices. Leader election rate. You are a doctor of Kafka cluster. You are diagnosing the problem. So how doctor diagnose the problem? Looks at the blood pressure, looks at the temperature, right? Doctor will look into all these parameters. So similarly, you are a doctor. So you have to diagnose these issues through various JMX matrices, which are indicator of good or bad health of the cluster, right? So these are like matrices. Now there are many others, but I'm just getting started with monitoring. For monitoring, we can even have a separate meetup like Kafka monitoring. It is a dedicated topic in itself, but it is related to performance. So that's why I thought of introducing some of the monitoring matrices. So when you are looking at the cluster, so cluster performance optimization, you have to see many things. For example, you have to see like what is happening with my requests. So there can be producer send request. So this is called producer request. There can be a request which is called fetch request. And this fetch request can be of two types. One is follower fetch request. Another one is consumer fetch request. So when you are looking at cluster performance optimization, you have to monitor the time, how much time each request is taking. If you look at the content monitoring. So in that, you will see there is a JMX metric, total time, millisecond. So this is a very important JMX metric to know how much time I'm spending, right? So if you have to debug the problem, first you should identify where is the problem. So in order to identify that problem, you have to look into the metrics. So this one is total time millisecond, and there are 3 types of requests which are possible. One is produce, another one is fetch consumer, another one is fetch follower. So there are 3 types of requests that I am talking about. So you need to see which one you want to focus on, like depending on where you see the problems are there. So produce request means, this is like produce request means that how much time it took to produce the messages from the write the messages from the producer side, right? Produce request. Fetch request, there are 2 types of fetch requests. One is like consumers are fetching data from the Kafka brokers, and second thing is like a replica fetch request. So when consumers are consuming data from Kafka, these are read requests, right? So how much time read requests are taking from consumer side. And replication requests, like when data is replicated within Kafka cluster, then how much replication requests are taking time, right? So from followers to, like followers are fetching data from leader partitions, how much time it is taking. So it is about that, right? So now when we are talking about performance optimization, you have to ensure that you are sticking to the default, like it is recommended, like there is a default configuration, which is message max bytes, which is 1 MB by default, 1 MB by default, and it is recommended not to change it. Message max byte, 1 MB by default. We don't want to change it, right? And if you have messages bigger, like larger than 1 MB, then you have to see other opportunities, like you can store those messages in blob storage or HDFS and send the URI of the URI of the message, like in the Kafka. So you will not be sending the entire video or like large messages through Kafka. Yeah. So apart from that, like there is another property. This is like default is recommended, don't change it, right? There is another property called number of network threads. So this number of network threads, very important property. So in case you are having very first thing is, what is this property? So in order to understand this property, you have to go to Kafka documentation, and you need to go to broker configs, and you need to go to num network threads, right? So I can search, but I will quickly scroll down and show you. This is and yeah, this is the property that I am talking about. And here you can see that by default it is 3. And what exactly this property says, the number of threads that server uses for receiving incoming requests from the network and sending responses to the network. Yeah. So requests are coming and they are addressed or received by these threads. So if you have secure cluster, definitely in production you will have secure cluster, then you have to change this value. 3 will not be sufficient. So you can double this value, maybe change this value so that you have encryption and decryption happening, like endpoint, SSL endpoint. It can take care of that part. If you have a non-secure cluster, then it's fine, like you are keeping 3, but you can increase it depending on how good is your machine, depending on the hardware of the machine that you are using. But number of network thread is one property which will help you in tuning the performance. Let's say producers are like producing the requests and a lot of requests are coming and you don't have sufficient handlers, like the sufficient network threads, then it will be a bottleneck. Yeah. So this can be one important property. Another important property is number of IO threads. If you go to the documentation, you will find that these threads are used for processing your request. For example, after network threads receive the request, it goes into a request queue. And after that, from there, it will be picked up by number of network IO threads, and it includes disk IO, like from page cache. So from page cache to disk. So from request queue to page cache and disk interaction. So number of IO threads are 8. Right, so you can tweak this value also to improve the Kafka performance. Yeah. Apart from that, how number of network threads is different from Java threads. Okay, so this is a configuration which is specific to Kafka, and this is like interacting with the incoming requests which are coming. So, you know, Kafka framework is designed in a manner so that the threads, if you see number of network threads are basically those threads which are handling the requests which are coming, right? So the requests which are coming. So Java threads are like Java is an application programming language. When you are building applications, then you are creating your own threads, right? So right now, the communication between the producer side client libraries and the broker side is already written. So the way communication has been written, so in case you need more requests, more parallelism, so it's like externalizing the parameters. So if you are writing your own code, then you are writing your Java threads. But the way the client and server communication, the client and broker side communication, which is written, it has externalized this parameter so that you have an ability to tweak this parameter and increase the number of threads that we have on the server side or the broker side so that more requests can be handled. So internally, this is written in Java only. Kafka is written in Java only. Yeah, but it is more like externalizing this parameter so that this can be tweaked without restarting anything. Yeah, that's the benefit. But so if we can see, like if this is like cluster wide. So this property is not read only. That means there is no restart required. So it is a dynamic configuration, cluster wide. But if it is written read only, then restart would be required. So every property you can see where the restart is required, where we don't need restart. Okay, great. Thank you for asking this. So now this is number of IO threads. Apart from that, there are other matrices also. You have to see JMX matrix, JMX monitoring. You have to monitor through JMX. And you have to see like how many requests are idle, right? And let's say network processor average idle percentage. You have to see these. Like if you go to the documentation and if you just search for threads, I want to show you this one. Request handler. How will you get to know? You have to increase this property. Yeah. So you will get to know when you look into these JMX matrices. So if this value is 0, that means all threads are busy. 1 means all threads are available. So it will be a value between 0 to 1. Based on this value, you can find out. So if this is actually below maybe 0.3, then it's a alert situation. You should be cautious about it, right? So through this, you can monitor how many threads are being utilized. JMX metric will give you this. Yeah. Now, overall, you have to monitor a lot of things like total time, millisecond. I was saying like JMX metrics, and then this one is also JMX metric. So you have to monitor these JMX matrices to ensure that you are not making making mistake and you are not able to identify the problem. So in order to identify the problem, you have to see these JMX matrices and you have to tweak these parameters, right? So it's very important when you are working with Kafka. So we have to tune many properties, tune GC garbage collection, because that is also important. So for GC tuning, there are multiple things like choosing a garbage collector, right, for your JVM, and then you have to choose other things like you have to do logging, enable logging, you have to enable. Yeah, and then you have to specify the log file path. And there are like many other GC parameters. And what are these GC parameters? If you go to Confluent documentation, fine. Running Kafka in production, go to this link, and here you will find the recommendations of what all parameters we should use like for GC. And Confluent has already got first-hand experience deploying, so we can rely on these numbers. So I just want to highlight that. So what are the best practices and recommendations? So these are some of the parameters that are recommended for GC tuning. Yeah. So this is one interesting document, which is Kafka deployment. So just have a look, but you need to understand Java memory architecture before this can be understood completely. Maybe if you want, we can have a separate meetup on Java memory architecture and how GC works and how to tune GC, other things. Okay, so coming back here, this is GC and which all parameters we have to choose, right? So there are many tools available on internet. Apart from that, like when we talk about cluster, it is also important to monitor and see like how my partitions are on the cluster. So you will be doing it through various tools, and these tools can be like Confident Control Center, or there are other tools available. So there are many tools available, but right now you have to first plan your capacity very well. So how do we like look into the number of partitions? Yeah, so number of partitions for a topic. What is your strategy? How we are planning that? Yeah, so in order to decide number of partitions for a topic, so in order to decide number of partitions for a topic, you have to like calculate it. How do we know if a topic needs 5 partition, or if a topic needs 50 partition or 500 partitions? How do we know? So you can get to know by applying formulas. And this formula is, you need to know your target throughput. You need to know what is the throughput of one producer. And then applying this formula, you can find out what is the optimal number of partitions. This is number of partitions equals to, this is a formula. Maybe rule of thumb you can follow. It's not necessary that you will always follow this formula. It is rule of thumb. That means it's fine. Like it's one general guideline. So P stands for producer throughput per partition and consumer throughput per partition, and T is target throughput. So based on that, you can easily calculate. Let's say target throughput is let's say 100 Mbps, right? And producer throughput is per partition is 10, and this is 100. So this is, let's say, 5. So you divide 100 by 10, you get 10, and here 100 by 5, this is like 20. So max of 10 and 20 is 20. So number of partitions for this particular topic is 20. Yeah. So by this way, you can calculate how many partitions are needed, yeah, for my topic. And there are so many other configurations that you can consider, but you have to look into the JMX matrices again and again. What is the problem? If my timeouts are happening, Zookeeper session timeout is happening when a Zookeeper session is expiring, then it's like a problem maybe on the broker side only, and you have to look into if there is a lot of GC happening, or if there is any other issue, like why brokers are not able to send heartbeat to Zookeeper. And if that happens, the cluster is unhealthy, and because of that, leader re-election is happening in the cluster. Yeah, you have to monitor active controller count. It should always be 1. Yeah, and look into the issues. If there is any deviation from these JMX matrices, then what could be possible issues? You need to look into that. So there are many other configurations on the cluster side. You will find there are configurations related to the topic side also, topic level parameters. For example, you are choosing cleanup policy. So are you going for delete or compact? And you have to see whether your compaction is running fine on the cluster. What is the dirty ratio? So multiple parameters you have to see before you can say that my cluster performance is fine or not. Yeah. Now, what about consumer side? I hope you are getting some sense, like cluster side is okay. You've got some sense. Now, if you have to tweak the consumer side, this is like, I will write on, this is consumer side. Now for consumer side, we have many opportunities again to look into various parameters. So one parameter is partition assignment strategy, which is partition assignment strategy. And this indicates which partition should be assigned to which consumer, right? So this is like which partition should be assigned to which consumer. So this is a strategy, and there are many different type of strategies. One is range, another one is round robin, another one is sticky, another one is cooperative sticky. So many strategies are there, but you can decide the strategy based on your needs, requirements. Yeah, it's a dedicated topic. It will require some time to explain, but I'm just thinking like consumer side, these are some of the key configurations that you have to see. Okay, now in consumer side, we have many other configurations. So there is a heartbeat interval, right? So when I need to explain first consumer group protocol and other things, like how overall the process works. And then I will be talking about the configurations, because that will make much more sense. So let's do that. So what happens in my Kafka cluster? This is my Kafka cluster. And this is my consumer side, consumer group. And within Kafka cluster, we have various machines. This is another machine, this is another machine, this is another machine, another machine. So this is my cluster, Kafka cluster. This is my consumer group. So very first consumer which joins this consumer group is called group leader. This is consumer one. This is consumer one, and this is called group leader. And then we have more consumers joining this group. This is more consumers, C2, C3. So we have consumers. This is C2, C3. And then we have these like partitions which are being consumed by these consumers. So what happens when we have consumer group, there is a property called group.id, which is a unique identifier for this group. So this is group.id. And this group.id, based on this, we can figure out which is my consumer group coordinator. So there is one group consumer group coordinator. So there are so many machines running in the cluster. One of the machines will get a responsibility of becoming group coordinator, and it is based on a hash formula. Yeah, hash of this group ID and module number of brokers. Then you will identify that one of the broker will become a consumer group coordinator. So this is consumer group coordinator, and this is a thread. Actually, this is a thread on broker side. This is a thread on broker side, and this thread is actually getting heartbeat from all the consumers. So all the consumers will send heartbeat to group coordinator. This is heartbeat going, and this heartbeat which is going from consumer to group coordinator, there is a interval. There is a interval which is called heartbeat interval millisecond. So this is heartbeat interval millisecond. There is a property. So this is another consumer side property which you can tweak. And there is a property called session timeout millisecond. So I will go back. This is heartbeat interval millisecond, which is 3 seconds. And then another one is session timeout millisecond. This is 10 seconds. So it should be like more than 3 heartbeats are missed, then we consider consumer is dead. So there is a heartbeat going based on which we identify consumer is up or consumer is dead. Yeah. So based on these properties, you will find out whether the consumer is dead or not. Like group coordinator will find out, right? So these are some of the interesting properties. Now, consumer side, we have a property called auto commit, like enable auto commit. So if you go to the Kafka documentation, and here you will find there are consumer side configurations. And I'm going to, this is interesting one, fetch minimum bytes. And then I'm going to this heartbeat interval. And then there is a property which we were talking about, enable auto commit. Yeah, so this is the property. If you go down, auto commit. So I'll search. So auto commit, I will just search Control F. Auto commit interval millisecond, which is after every 5 seconds. And then there is another property, enable.auto.commit. Yeah. So this is set to true by default. That means in consumer side, it will commit the offsets automatically. Yeah. So which is not a good idea in production. So enable auto commit is there. So we should turn off that property to do manual commit. Enable auto commit. Enable, sorry, there is a problem with my, okay, enable auto commit. Okay. So this is by default set to true, and we should look into that and set it to false. And then there is a commit interval, which is 5 seconds, which I have just shown. Now, after this, like I was talking about, in consumer side, we have other properties also, which are very interesting property based on which performance will change. So you remember in producer side, we were talking about the batches which are going from producer to the Kafka broker. Same thing like consumer also the consumer is pulling data, producer is pushing data to Kafka. When consumer is pulling data, then there are two configurations. One is like fetch max bytes, which is another important property. So you need to tweak this property. Yeah, so there is a property called fetch min bytes also. So you have to change the batch size, right? So when you are pulling information from Kafka consumer, so do you want high throughput or do you want low latency? If you want high throughput, then this fetch min bytes, by default it is 1. We should change it to a high value. This fetch min byte, this property, right? Fetch min bytes. So this value should be bumped. We should increase it to get high throughput, because you are reading only 1 byte. By default it is like that. And there is another property which is fetch wait max second millisecond. Fetch wait max millisecond. Yeah, this is based on time and this is based on size. This is based on size and this is based on time. And whenever, like whichever is the condition is met, then it will trigger the batch to complete and then consumer will hold data. So we have hold timeout also, but in the batch size that we are talking about, like this is like how much amount of data that we have to accumulate, like how much data we have to accumulate. Yeah, so before sending a response to the consumer, right? So this fetch dot min dot bytes and fetch wait max millisecond, very, very important properties. And they control if we are able to achieve high throughput or low latency in Kafka, right? So when we say performance optimization in Kafka, we have to think about, again, going back here, high throughput versus low latency. So there are use cases where you need high throughput. There are use cases where you need low latency. So producer side also, you can set up high throughput, low latency. Similarly, we discussed, this is our, again, broker side or cluster side configuration. So maybe you have to look into replication side configurations which are related to high throughput and low latency. You have to change the amount of data that you are fetching from like leader partition and follower fetching. Follower partitions are fetching that much data. And consumer side also, you have to see the configs, the key configs. And when you are looking at configurations, then you also have to see the matrices, JMX matrices, to complement the knowledge that you are having, because there, through these matrices, you can identify the problem in real time and you can fix up those issues through maybe configuration changes, or some, there are so many other ways through which you can look into the problem, right? So you can run data balancer, or there are other opportunities to improve the performance. So I hope you got an idea how do we work with Kafka performance tuning. 1 hour is not sufficient for this topic, but still whatever time we were having, we try to utilize it effectively, and we try to cover some of the key configurations which will help you in optimizing the Kafka performance. So this is our meetup group, and we conduct such kind of meetups on various topics, including Kafka, Spark, cloud, and a lot of other areas, DevOps. So we will be doing more meetups in future also. We encourage you to be part of this meetup group, and you can also join our YouTube channel where you can find videos related to a lot of these technologies. Yeah. So if you have any questions, you can stay back, ask questions, clarify things. Otherwise, that is what I wanted to cover today. Thank you so much for your time, and I will see you maybe in the future meetups. And these are the links that you can follow, and I would highly encourage you go for like subscribing our LinkedIn page, because there you will find a lot of interesting cheat sheets and free articles. So please do follow LinkedIn and YouTube. You will find a lot of free content there. Okay, thank you so much. I'll see you soon. Bye.